Welcome back to another one of my implicit differentiation videos. I'll be showing you how to apply the techniques of implicit differentiation to functions revolving around or equations that include ln of x or ln of a unknown. So anyway, let's get started. So we have our first example, and that's going to be ln of x multiplied by y equals 4x squared. So first step, derive both sides. With respect to x. Okay. And now, well, here we have, we're going to call this one, we're going to call x u and y v because we're going to need it, because we have a function multiplied by a function. Therefore, we need the product rule to solve. But first, we're going to need the chain rule as well to solve this, because we derive the outside, then the inside. So the derivative of the outside of ln of whatever is 1 over the whatever multiplied by the derivative of the inside, which will be u dash v plus u v dash. And that will equal the derivative of 4x squared. Now, we treat this like the chain rule. Derive the outside, leave the inside the same, and then multiply by the derivative of the inside. So, the outside, bring the 2 down, multiply by the 4, we get 8. The x stays the same, multiplied by the derivative of the inside, derivative of x with respect to x. Now, what we have here is we have 1 over xy multiplied by u dash, which is derivative of x with respect to x, multiplied by v, which is y, plus u, which is x, multiplied by the derivative of v, which is derivative of y, so derivative of y with respect to x, equals, I'm just going to say 8x, because 8x multiplied by this here is equal to 1, so I'm just going to say 8x multiplied by 1 is 8x, which is what I'm just going to write here. Now, you can see we have a dy dx in here, and usually when I have set up like this, I would expand the brackets, and so we can open it up and we can start shifting around to try and find dy dx, but because it's not that complicated in this case, I'm just going to multiply this on both sides. I'm just going to multiply this to both sides. And then multiply this on both sides by bringing it up. Okay, so I'm going to multiply x multiplied by y to both sides. That will cancel out this, and we'll be left with dy dx multiplied by y is just y, plus x multiplied by dy dx equals 8x multiplied by xy. Okay, so bringing it up to the other side. Essentially, we're multiplying both sides by xy, but you can just bring it up. Anyway, so we've got y plus x dy dx equals 8x squared multiplied by y, because x times x is x squared, multiplied by y, you get the picture. Now, what we're going to do is going to subtract y from both sides, which will get rid of this bunch, and we'll be left with x multiplied by dy dx equals 8x squared multiplied by y, take y, and now we'll divide both sides by x, which will cancel out this and leave this. Therefore, the derivative of y with respect to x is 8x squared multiplied by y, take y over x. If you wanted to go a step further, you could factor out the y, and we'd have 8x squared take 1 y x. Okay, now on to our second example. Here we have ln of x plus sine x equals xy. Okay, just like before, we find the derivative of each side. Okay, just like with ln, we just have 1 over whatever's in here. We multiply it by the derivative of whatever. So the derivative of x is just derivative of x with respect to x, plus derivative of sine x is cos x, which will equal derivative of x multiplied by y. We already said this before. I'm not going to rewrite it up too much, but we have it here. So I'm just going to use this because it saves time. So we have the derivative of x with respect to x multiplied by y plus x multiplied by the derivative of y with respect to x. Okay, so well, this is 1, so I'm going to have 1 plus cos x over x plus sine x, because this just multiplies on top of the fraction, equals y, because 1 times y is y, plus x multiplied by dy over dx. So what I'm going to do is here, just have 1 plus cos x, x plus sine x, minus y, because I'll just subtract y by both sides, equals x multiplied by dy dx. Now to make this look neater, I'm going to give y, I'm going to multiply the top by x plus sine x. I'm going to have x plus sine x divided by x plus sine x. They essentially cancel each other out, but it'll allow me to put y on top of this fraction. I'll show you what I mean in a minute. So 1 plus cos x. If I have y multiplied by x plus sine x, and I have x plus sine x equals x dy dx. I haven't done anything tricky here. I've just, for y to have the same base, I have to not only have it on the bottom, but I have to have it on the top as well. So I have to multiply y by x plus sine x over x plus sine x. That way I can give it this. That way I can give this and this the same base as such. And I know it seems like I'm complicating it. I'm making the situation worse, but I did that because if I'm going to divide both sides by x, and if I do that, it'd be more like multiply by 1 over x. Okay, that means that this will cancel out, and this x will be multiplied into this, and it will look like dy dx equals 1 plus cosine of x minus y bracket x plus sine x over x bracket x plus sine x. And that there is your final answer. Alright. Thanks for watching this video. I hope you learned something, and I hope you have a good day.